video, we are going to discuss a problem statement related to parallel programming. So we are given a task in which we want to schedule n tasks on m cores with some constraints. The constraints are such that each of the tasks can be executed only if the previous tasks are already scheduled. They need not be finished, they should be scheduled. Other than that, we are given the priority for each of the tasks. Multiple tasks can have same priority. Now, if we have mapped the priority to some core already, now all the future tasks with that priority should be executed on the same core. If we haven't mapped the priority to the core, then we can do that, and it should be mapped such that we are always choosing the free core with the lowest index. Let's try to understand the problem statement better by defining the input space. Let's say we want to define 10 tasks on 3 cores, and we are given the execution time for each of the 10 tasks, and we are also given the priority for all the 10 tasks. Now our output is such that we are reporting the end time for each of the 10 tasks. So now task 0 is having priority 1, and priority 1 is not mapped to any core yet. So we are going to choose the core with free core with the minimum index. For when scheduling task 0, all the cores are free, and core 0 is the core with the minimum index. So we simply choose task 0. We simply choose core 0 for task 0. And we also say that the core priority 1 is mapped to core 0. Now the task 0 is scheduled, we are free to schedule task 1. So task 1 is given the priority of 0. 0 hasn't been mapped to any core yet, and core 0 is busy at the moment. So we'll map it to core 1, which is the core with the free core with the minimum index. Now the task 1 is scheduled at core 1, and priority 0 is mapped to core 1. Now we move to the next task, which is task 2. We see that task 2 is having priority of 0, and we have already mapped the priority 0 to core 1. So task 2 should be executed only on core 1. But since core 1 is busy, we'll have to wait. So similarly, we can go for all other tasks. Now let's get into the code. So we need to have some kind of locking mechanism to ensure that the future tasks are not getting executed unless the previous task is executed. So we have this kind of statement where initially we initialize task schedule status to be 0 at for all the tasks. Now, when thread 0 executes, once it sees it, it's gonna execute it because index is always 0. The statement is gonna violate. So thread 0 is always gonna evaluate it to false. It's never gonna get stuck in this loop. While other thread, which is thread 1, let's say, now thread 1 is gonna get struck until we unlock this thing using thread 0. Similarly, thread 2 is gonna get locked until we unlock this with thread 1. So this kind of thing has introduced some kind of locking mechanism for all the future threads unless the previous threads gets executed. So we are handling this appropriately at the end of the code also. We'll move to that soon. And then we are simply loading the priority for that particular task which we are executing currently using into the buffer, into the registers. And then we are also loading the priority to core map. Priority to core map is initialized to -1. If -1 indicates that we haven't allocated any core to the particular priority yet. So either core index would be -1, which means that priority is not mapped yet, or it would be some 0 to m-1 cores based on the priority which has been assigned already. Now, if the core index is -1, which means that if the priority has not been set, we simply choose the priority. We simply set the priority. So this particular snippet is simply choosing the free core with the least index. So once we get the core index, we simply set the priority to core map to that particular index for that particular task. Now, this is the main crucial component of this problem statement, in which we simply check if the particular core which we have just found out is free or not. If it's free, then we are free to schedule the task at the particular moment. So we won't go into this particular if statement. But if it's busy, then we'll have to wait until this particular core is free. So we find out when the core would be busy, by when the core would be free using this core busy time. We set this core busy time at the end of uh, each thread, basically. So if the core is busy at the moment, we choose we find out when would the core would be free, and we reset the current time to that particular time, because at that time now the next task needs to be executed. And since we have updated the time to a new time, we'll have to check out what all cores are free now. So we do that with this for loop. And further, this is simply calculating the results, where we find out the final end time using the current time and the execution time for that particular task. We simply add them up and store the result back into the global memory using this. Now, these are some steps which would be useful, which we used in the previous slides, right? So in this, we simply set the core busy time to be the end time for that particular task, which were executed on some specific core. And we also say that the core is busy now. So we set core free status for that particular core to be 1. And in the end, now that the task is finished, our thread has done its job, we can simply set the task schedule status to be 1, which will unlock the next thread to proceed further. If we combine the complete code from the previous slides, we would get something like this. So here we are simply ensuring that the threads are get future threads are getting locked and are not executing any future task until the previous task is already executed. And then in this particular part, we are simply checking out if we have the core index. If we don't have the core index, we find the core index first. If we have it, we just use it directly. And then we check if the core is free, that particular core index which we got is for, now that particular core should be free or not. If it's free, then we can just update the result at that particular time only. If it's not free, then we update the time to that time when that core would be free, and then we update all the core status based on that time. And eventually we calculate the results, and then we set the core busy time and core free status appropriately. And then once everything is done, we free the next threads to move further. Thanks a lot.